Range of motion model of health. When I started range of motion 12 years ago, what I wanted was an umbrella that would encapsulate everything we did. So we could have an Olympic athlete walk in the door or a kid with cerebral palsy walk in the door, and we could have a model that would suit them both while at the same time allowing some degree of individualization, which is obviously necessary when there's so much range there. So what I created is what we call the range of motion model of health. And I touched on this a little earlier, but effectively it's a wagon wheel. About 8 years ago, I also wrote an article for the CrossFit Journal which talks about this and how we can apply it. So that would be a good one for you guys to look up. It's called weakness bias training, and you can find that in the CrossFit Journal. So this is the concept. You have a wagon wheel, and on the wagon wheel there are a whole bunch of spokes. These are the axes of our graph. And each one of these spokes represents a different element of your health or a different element of your fitness. So if we're looking at this from a general health point of view, one might be resting blood glucose levels. One might be bone mineral density, levels of anxiety or depression, how well you're sleeping. Anything that can be measured objectively or subjectively can be inserted onto one of these spokes. From a fitness point of view, strength, absolute strength, power, your speed, coordination levels, skill, stamina, all of these things can be attributed a spoke on this wagon wheel. Does that concept make sense to everyone? It's important you understand that because we build everything in this programming lecture from this model. Now, of course, you can have an almost infinite number of spokes on this graph. Can you see that? You could have 1,000 on there. And the more you have, the better a picture of your health, of your fitness we start to be able to create. So what we can then do is we can assign a score on a scale of 1 to 10 for each of these metrics. So maybe we're talking about absolute strength. And we've got an athlete who is really strong. They're a 9 up here. Maybe look at something like power. Now you'd expect someone who is pretty good at absolute strength is probably going to be pretty high in power as well. Maybe their cardiorespiratory endurance is not so high. It's down here somewhere. Their speed, okay. Their body weight ability is maybe something that really needs work. So we can assign each of these metrics a score on this graph on a scale of 1 to 10, and it starts to give us a picture of what that athlete looks like. Because once we know what that athlete looks like, we know what we've got to work with. Everyone cool with this concept? We start to put together a picture of that athlete. And again, we can have an almost infinite number of spokes on that graph. This is the model from which we then bias our training. This is how we say, well, this is what needs the most work. Because our contention is that just like a wagon wheel, as that wheel turns, even if you've got 1, 2, 3, 4, 5, 6, 7 super strong spokes, if one spoke is cracked or broken, that wheel's going to collapse. And once you've gone a full revolution of that wheel, it's going to fall apart. So, like I said, our contention is you are only as strong as your weakest link. You're only as proficient enough as you are strong in your weakest spoke. Now, if you're a professional sports person, the weak spoke is maybe what means you don't make the final, you don't kick the goal, you don't touch the wall first on the swim. From a health point of view, a weak spoke doesn't just mean that you don't qualify, go to the Olympics, win the gold, make the final. The weak spoke is the thing that's going to kill you. It's the thing that's going to cause either a premature loss of life or a reduction in your quality of life, some sort of disability. So you can see both from an athletic point of view and a general health point of view, this is a really useful model to say, well, this is what we need to work on. So how do we actually then apply that to programming? How do we make the jump from this to these are the exercises that I want you to do? This is the program I want you to do. Well, it's quite simple. These things down here, we need to spend a lot of time on, which is a positive and a negative. It's a positive because it's a really low-hanging fruit. If you're really weak at something, if squats are a weakness for you, there's heaps of room to improve, which means you can improve a lot very quickly. If you're amazing at pull-ups, it's harder for you to get a 20% improvement, which you could get in a squat. So there's a lot of low-hanging fruit here, but it also means that you have to spend a lot of time working on your weaknesses. we tend to not like the things that we're not good at. As soon as you get to year 10 at school and you start to choose what subjects you want to do, you choose the things that you're good at. It's human nature. Therefore, we get better at them. Therefore, we enjoy them more. Therefore, we choose them. We get better. We enjoy them more. And you get this feedback loop where we become more and more and more specialized. If you want to be a marathon runner or a power lifter, that's great. And you only need to work on one or two spokes. But we don't. We want to be generalists. We want to be equally proficient across the board. That's why we spend our time working on these. Now, the cool thing is, once you start working a weakness, you insert that into this cycle that we want. You start working a weakness, you become better at it, you want to do it more, you become better, you like it, and suddenly we take our model from looking like this to looking something like this. And that's our aim. We want to eradicate weakness with smart, responsible, biased programming to reduce any weaknesses through these spokes and then increase the size of that. And that's the summary of how we program and why we should program and bias towards a weakness in your training.